Hey everyone, today we'll be going over LeetCode problem 21, merge two sorted lists. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given the heads of two sorted linked lists, list 1 and list 2, and what we want to do is merge these two sorted lists into one bigger sorted list. And at the end, we want to return the head of this merged linked list. So we have an example here below which I've created, and we have two linked lists. The head of the first linked list is pointed by list 1, and the head of the second linked list is pointed by list 2. And we see that both of these lists are already in ascending order. Now what we want to do is create a new linked list, which is the result of the merging of these two smaller sorted linked lists. And because we need to create a new linked list, what we will do is use a dummy node as our head of the new linked list. This is a technique commonly used when we need to create a new linked list in a LeetCode problem because it allows us to avoid many of the edge cases which occur in creating a new linked list. So we have this dummy node as our head of the linked list, and because we're using this null node as our head, what we will do at the end is actually return dummy node.next as the head of our actual sorted linked list. So our approach will be to go and compare the heads of the two linked lists, see which value is smaller, and go and put that node as the next node in our new linked list. After which we go and move that pointer for that specific list to the next node along in the list. For example, we start with 1 for list 1 and 3 for list 2. So we know that 1 is smaller than 3, so we want to make that node with value 1 from list 1 the next node in our list. So we can go and take that node with value 1 and make it the next node in our list, and then move our pointer of list 1 along in that list. Now we compare the 2 and 3. We know that 2 is smaller, so once again we make this node from list 1 the next node in our list, and move list 1 along in our list. Now we compare 3 and 5. We know that 3 is smaller, so we make that the next node in our list, and move list 2 to the next node. 4 is smaller than 5, so once again we make the node from list 2 the next node in our list, and move list 2 along. And then we have 5 as the smallest node in our list, so we make that the next node in our new linked list. Now at this point, list 1 is done, and we know that list 2 is already sorted in ascending order. So when one of the lists terminate, all we have to do is make the next node in our new linked list the head of the only remaining list of the two. So by making this pointer from our node with value 5 to the node with value 6, which is our current head of list 2, we have terminated our algorithm. Now this algorithm has a linear time complexity, and this is because, as we see, we move both of the pointers for each list only once through their respective lists. So we are only visiting every node once, making our algorithm linear. So we said we're going to start off our algorithm by creating a dummy node. And this dummy node is going to be an empty list node, which will have no value. And we're using this in order to avoid many of the edge cases in creating our new linked list. And we are going to make our current node equal to this dummy node. So then afterwards, what we want to do is go through the two lists, list 1 and list 2, up until they are both not null. And during each iteration, we want to compare the values of the heads of the two lists. Now, if list 1.value is smaller than or equal to list 2.value, then what we will do is we're going to make that the next node in our new linked list. So we can say cur_node.next is going to be equal to list 1. And afterwards, we want to move the list 1 pointer along. So we could say list 1 is going to be equal to list 1.next. And finally, we want to move our cur_node pointer along. So we could say cur_node is going to be equal to cur_node.next. In the other case, where list 2 points to a smaller value, we will do the same for list 2. So we're going to say that cur_node.next is going to be equal to list 2. List 2 is going to be equal to list 2.next, so we move its pointer along. Let me make sure I include the numbers here. So list 2.next. And then we move our cur node pointer along as well. So cur node is equal to cur node.next. Now, once we fall out of this while loop, we know that either list 1 is done or list 2 is done. So if list 1 is not done, meaning that list 2 was terminated, what we want to do is make the next node basically whatever node list 1 is pointing to. And in the other case, if list 2 is the list that is not completed, we want to make the next node equal to list 2. And at that point, we have completed our merged linked list, so we could just return dummy.next. Now let's make sure this runs. And we see that it works and it's efficient. Thank you for watching this video. If you enjoyed it, please subscribe to my channel and give it a thumbs up. I'll see you on the next one.